Hi everyone and welcome. My name is Soumya Nagar and this is my presentation on Introduction to XML. Today we are going to talk about one of the most fundamental technologies on the web, that is XML or Extensible Markup Language. We will cover what it is, why it's so important, and how it is used in everyday applications.
Here is a quick look at our roadmap. First, we will cover the big question, what is XML? I will also explain what it's not. It's not a programming language. Then we will talk about the X in XML, which stands for extensible, and it's the key to understanding its power. After that, we will cover up the most common point of confusion, the difference between XML and its famous cousin HTML. Next, we will look at where XML is actually used in the real world. Then, we will look at a simple XML file together and break it down piece by piece, looking at its key components. We will also cover the golden rules that every XML document must follow. And finally, we will see how a software application like one written in Java or Python actually reads and understands an XML file. By the end, you will have a really solid grasp of the entire concept about the introduction to XML. So let's start with the most basic question. What is XML? The name again is Extensible Markup Language, but let's ignore that fancy name for a second. At its heart, XML is just a text file. It's a simple text-based format that was invented to store and transport data. That's its entire job. It's not a programming language. You cannot use XML to write a program, calculate number, or build an app. It does not do anything. It's not a database. It's just a file. It's a markup language, not a programming language. Here's the best analogy. If your data is packaged, XML is the shipping container. It's a standardized box that you put your data into. Because it's a standard format, any application that understands XML can open the box and get the data out. No matter what that application is, what language it's written in, or what computer it's on. The other key feature is that XML is both human readable and machine readable. This means you can open an XML file in a simple text editor and understand what the data is. And a computer can also read it very easily. This makes it incredibly useful as well as you see.
This is the most common point of confusion, the difference between XML and HTML. Both XML and HTML use tags, but their jobs are totally different. HTML displays the data while the XML describes the data. The tags in HTML is predefined. Like H tag always means this is a top level heading. Its purpose is presentation. XML is extensible. Like the tag student means you're describing a student. That's why you created a tag student. If you're describing a price, then you create a tag price. The focus of HTML is on how data looks. The presentation of the data matters in HTML. But the focus of XML is what data is, the structure of the data. The HTML is not case sensitive. Tags are not case sensitive. But XML is case sensitive. Error handling in HTML is lenient that because browser tries its best to display a page to the client without an error, and error handling in XML is strict. An XML document must be well defined and well formed before displaying.
Okay, so this is all a nice theory, but where is XML actually used in the real world? The number one use is data exchange. Imagine a big bank, their main computer might be 30-year-old and run a language called COBOL. Now they want to build a new modern website in Java. How does the new Java website get your account balance from the old COBOL computer? They can't just talk to each other, they speak different languages. This is where XML comes in. The old COBOL system can package the data, your name, your account number, your balance, into a standard XML file. It hands this shipping container over to the Java system. The Java system knows how to open XML files, so it takes the data out of that and displays it on the website. XML is a universal translator. It's a neutral ground that all different technologies can agree on. Another huge use of XML is in configuration files. Many applications like web servers or software projects store their settings in XML files. Almost every piece of complex software you use, your web browser, your video games, your programming tools, web servers, etc., needs to store settings. Where do you put them? Often in an XML file. Why? Because it's easy for the developer to read and edit, and it's easy for the programmer to read when it starts up. It's a clean, structured way to store a list of options, settings, and preferences. Continuing on, XML is a backbone for many web services and APIs. When you use an app on your phone, like a weather app, how does it get the forecast? Your phone sends a request to the weather company's server. The server packages up the forecast, temperature, humidity, change of rain into an XML file and sends it back to your phone. Your app then reads that XML and displays pretty graphics. This happens billions of times a day. Now, note that today another format called JSON is also very popular in this, but XML was the original and is still used in many systems, especially in enterprise level applications. Finally, Finally, many document formats you use every day are secretly XML. Even used a Microsoft Word document, a .docx file. If you were to change the file extension from docs to zip and unzip it, you would find a whole bunch of folders and XML files inside. The main XML file document.xml contains all your text, all your formattings, all your headings, all described in XML tags. The same is true for SVG vector graphics, which are images defined by XML, and RSS feeds, which power all the podcasts you subscribe to, are just XML files.
Let's look at a simple example. This XML document describes catalog of books. You can't immediately see the structure. We have a main catalog element. Inside that, we have two book elements, and inside each book, we have more elements describing about the book, like author, title, price, etc. Notice how the tags I am using, like author, title, clearly describes the data they contain, which is what XML is so powerful. Now let's understand the key components of XML, that is prolog and root. So the first is the XML prolog. Let's break that example down. The first line, XML version 1.0 encoding UTF-8. This is called prolog or declaration. It tells the computer what version of XML this is and what characters encoding to use. Below that, we have the most important rule. Every XML document must have single root element that wraps everything else. Another example, like catalog, is the root element. Every XML document must have only one root element, and this element contains all other elements. It is like a parent to whole of the document. Now, the most important building block of XML are elements. An element is everything from its opening tag, like price, to its closing tag, price. including the content in between. This is a complete element. So element is an entire unit from its starting tag to its end tag. Content, the data between the tags like 44.95 is the element's content. Weak elements can be nested inside each other to create a structure. Like author, title, genre are children of the book element, as we have seen in the example. This parent-child tree structure is a key to how XML organizes data.
So now we have attributes. An attribute is a little piece of extra information or metadata about an element. They are placed inside the start tag. It's always in name is equal to value pair. Attributes use values must be in quotes. Look at our books tag. Book ID is equal to BK101 is an attribute value. Attributes are used to provide metadata about an element. In this case, the ID attribute is giving the book a unique identifier, which is a perfect use for it. The ID isn't the data itself, it's a metadata about the book data. This brings us to a classic beginner's question: when should I use an element and when should I use an attribute? For example, I stored the book's ID as an attribute as I have shown in this example, but I could not have just as easily stored it as a child element like the element book, then ID BK101 ID tag closed, then book tag closed. The answer is yes, I could have. Both are correct XML. So, how do you choose? Here is a general rule of thumb that most developers follow. Use elements for the core data, the data you expect the person to want to read. Think what the data is: the author, the title, the price. These are the data of the book. Use attributes for metadata. This is data about the data. An ID is a perfect example. A language code like title lang is equal to en would be another. It's not the data itself, but it's a description of the data. When in doubt, using an element is almost never the wrong choice, but using attributes for ID and simple metadata can make your XML cleaner and easy to read. This is probably the single most important slide in the presentation. HTML is very forgiving. If you forget a closing tag, your browser will make a guess and try to display the page anyway. XML is not forgiving. XML is strict. An XML document that follows all the syntax rules is called well formatted. If there is a even one single error, the entire file is considered malformed or broken. Any program trying to read it will stop, throw an error, and refuse to process it. Here are the golden rules for a well performed document. First, it must have one and only one root element. Every single element must have a closing tag. In HTML, you can just write BR tag. In XML, you can't. You must either write BR and the closing tag for BR or use a special self closing tag for that purpose. Tags are case sensitive. Book and book are two completely different and unrelated tags to an XML parser. Elements must be properly nested. This is a stacking box rules. If you open a B tag, then an I tag, you must close the I tag before and you should close the B tag. Last and first out. All attribute values must be quoted. These are the 5 rules you have to follow to form a XML file. So, for our last topic, how does a software application actually get the data out of these files? A Java, Python, or C hash program does not want to read this file line by line and try to figure out where the tags are. That's difficult and slow. Instead, every major programming language has built-in tool called the XML parser. The process, the parsing, and the application does not read the XML text directly. It uses a built-in library called as XML parser. Your application, let's say it's a Java program, hands the catalog.xml file to the parser. The first thing the parser does is, if the file is well formatted, it checks all of our golden rules. If it finds one mistake, it stops and tells the Java app this file is broken. If the file is well formatted, the parser does something very clever. It reads the entire file and builds that family tree structure we talked about. It builds it in the computer memory. This is memory tree is called the DOM or document object model. Now your Java application has the nice neat tree object. It can easily say, hey DOM, please get the root element. Okay, now get all of its children's. Okay, for the second element, find its price element and tell me the content. This is how application reads XML. They don't read the text, they read the tree structure that the parser builds for them. So have a quick recap of what we have learned in this video. First, XML stands for Extensible Markup Language. Second, the main of the XML is to store and transport data, not to display it. That's HTML's job. Third, it is extensible. It is a superpower. It means you invent your own text to perfectly describe your data. Fourth, XML is organized in a parent-child tree structure with a single root element at the top. It is human readable and relies on user-defined text. The key components of the XML is prolog, root element, elements, and attributes. XML is strict but is a well-formed, which means following five golden rules like closing all tags and being case sensitive. And finally, applications are built in tools called an XML parser, checks it for errors, and built-in memory tree called the DOM. It's a foundation technology for data exchange, configuration files, and web services. And that's your complete introduction to XML. We have gone from the basic idea to the technical rules and all the way to how it's used in the real world. It's a simple, powerful, and fundamental technology that holds the digital world together. This is my presentation for Introduction to XML. Thank you so much for watching.